proton equal 2 positrons plus 1 electron equal a charge of plus 1. A thought experiment. The key to matter. This thought experiment will, if correct, resolve these two major problems in physics. This explains why a massive proton has the exact same charge as a tiny, tiny electron. This explains where the missing antimatter is. The missing antimatter is in protons and neutrons. The missing antimatter is right in front of us. This thought experiment will also challenge the 3-quark model with a 3-particle model of 2 positrons and 1 electron. See illustration. The proton in my model is made up of 2 positrons in an orbital around a single electron. That means the proton is 2 positrons with positive charges and 1 electron with a negative charge. That balances out to exactly 1 positive charge. This matches the negative charge of an electron. Therefore, the charge of the massive proton is exactly equal to the charge of a much, much, much tinier electron. Why don't they annihilate, though? There is a major stumbling block to this thought experiment. When a positron and electron meet, they annihilate into photons. So how does this model answer that major problem? First, 2 key points. Protons cannot be made today. There is something about how they were made that can only be recreated in Big Bang-like conditions of extreme heat. Protons are so stable that they may be virtually immortal, while a free neutron will decay in 10 to 15 minutes into a proton, an electron, and anti-neutrino. So, for an electron and positron traveling near the speed of light, they have to be 1 to 4 femtometers close to annihilate. That's about the diameter of a proton. That's almost a situation where the positron and electron are touching. That means that if these particles are moving extremely quickly, then they have to be very, very close to annihilate. The rule is this: as the velocity approaches the speed of light, the probability of annihilation decreases. For an electron wave and positron wave to annihilate in destructive interference, they have to be mirror waves and their wave functions must overlap. For instance, electrons in different orbitals have different wave functions. The 2 positrons in my model are in an orbital and fill it up, while a single electron is not in that orbital. Therefore, they should have different wave functions and not annihilate. BHA scattering, scattering, is a process at extreme high temperatures where an electron and positron will interact but not annihilate. Finally, 2 electrons in the same orbital will have a magnetic strength of 0 because of opposite spins that cause their individual magnetic moment to cancel each other out. So, let's look at the illustration again. The 2 positrons are in an orbital that should cancel their magnetic strength. The electron in the center has a different wave function than the 2 positrons. This should prevent annihilation. They seem to be close enough for annihilation, but somehow the Big Bang conditions prevented annihilation and instead produced an incredibly stable configuration, the proton. This concept for the proton is part of many posts, videos, and articles on protons, neutrons, atom structure, hydrogen makeup, and much, much more. Thanks for reading. You are welcome to share.